Hello to today's session on truthfulness and retrieval. So there is a core problem in how LLMs work, which you might have faced already, is that LLMs are trained to generate human-like text, so text that seems plausible, not true text. And there is nothing by itself that indicates truthfulness to LLMs. So the idea is, however, since you are interested in actually having replies that are true, you want to ground the LLMs in reality so they don't make stuff up. So one way to do that is to include relevant knowledge in the context of the LLMs. So basically how that works is you have we as users, we want to get an answer to something. The LLM basically retrieves first information based on your question out of a knowledge base. So for example, the internet, or if you're applying your LLM in a business context, maybe there are some internal documents that are in a knowledge base somewhere. And then you basically give a prompt to the LLM where you ask your question and say, this is relevant context, base your answer on this context. And then the LLM will try to answer your question with the context that is given to it. And as a result, we hopefully have a better answer, better than just creating plausible text. Here the question is about retrieval confidence. So basically, since you have this additional step here, the question is, did the query actually find the right material that's relevant to your question? Also, source quality matters, whether it's actually gives you current, independent, and appropriate information that helps to answer the question. The big question is also, does the source actually support the exact claim? So the question of entailment is important, not that the LLM just, you get some kind of source to the LLM and it kind of invents some kind of entailment. That can happen as well. The generation faithfulness is also of importance. So did the answer actually preserve what the source says? Since this main task is still to answer your question in the first place, it might not just repeat the whole context that it has, but maybe it is interpreting the source in a special way that actually changes the faithfulness of it. Also, the coverage is of importance, whether all important claims were checked. So retrieval can be useful and is useful, but it also shifts the uncertainty, because there can be, you have so many additional steps here that the uncertainty is very difficult to judge. Those search rankings, so which knowledge is actually given to the LLM, then can omit relevant evidence. Also, the corpora can be biased, so if the training data itself just has biased information, obviously the LLM will be based on that. And also the, and as before, an LLM judge can also share generators' mistakes. Okay, another method to deal with uncertainty in LLMs are basically conformal predictions for LLMs. They are called conformal factuality. And the idea is that you have basically various LLM outputs that are progressively less specific, and you want to increase basically the size or the set of your answers such that the correct answer is guaranteed to be contained in those sets. So this looks like that. If, for example, the input question is, where was Abe Lincoln born? The actual real answer is in Kentucky, or basically the whole real answer, or the most specific real answer is the Sinking Spring Farm in Hodgenville in Kentucky. And you can have basically confidence sets that say that the larger the set, the more probable it is that the true answer is contained. And it just works like conformal predictions, where you increase always the set of possible answers. More specifically, the sets are: first, we generate answer. So this is basically the base answer that we get. We decompose this base answer to turn it into atomic subclaims. So basically, if you get a very long sentence and it explains some things, you really want to get the decomposition of those subclaims. You then score each of those claims that we have. So this is basically the concept of self-evaluation that we talked about before. So every claim gets a reliability score. And basically the best tested scores, it counts how many of, for example, 5 independently sampled alternative actually support this claim. Then you calibrate it offline. So this is basically like training phase of your conformal factuality. And then basically on each of the labeled calibration examples that we got in the step before, we figure out what is the score of the highest score of a false claim. So where did the model wrongfully give a very high score to a false claim? And this is basically then this minimum back-off level. So those are the examples that we really need to remove so that we can remove the false claims in our example. Then now we're coming to the inference time. So now we're actually using it on new data. We have now a new unlabeled input, and we again ask it for the confidence scores, and then we only keep our claims where the scores are higher than what we had calibrated before, and keep only like the true claims. And in the end, we again, the last step is that we prompt the model to combine only those claims that we kept here at step 5, and if not a single one is kept, we abstain from the answer. Okay, so you can see conformal prediction, this conformal factuality, it was shown to work quite well with some fact knowledge, but again, it's kind of difficult because we really need this calibration set where we actually know for real that certain claims are true or not true. And depending on in which setting you want to use this, it might be difficult to actually obtain this calibration information. Okay, wow, no, we looked at many different methods now in how to quantify uncertainty for large language models. So I created like an overview slide for you. We will not go through everything here in detail, but I wrote down like the core intuition of the method, what is needed, so what kind of access do we have? Do we need actually the weights, or how costly is it to get it, and some of the main limitations. So if you're trying to choose which method works best for you, maybe you can first look into this table and then only later on decide. We thank the Deutsche Forschungsgemeinschaft for funding this project, our copyright, and goodbye everyone.